Can everyone see my screen?
Alright, so our presentation is on the stock price and predicting it. And it's by DT, Shiloh, Isabel, and Josh, which is me. And then we process the data. Wait, yeah. So we process data by separating the stock data based on their dates, opening, closing prices, highs and lows, and their sales density in the trading season. And we use that to find the percent change per day to estimate their growth by using a linear regression model to visualize the predicted growth rate and forecasts. And we also use the Heston model to represent the volatility and their past levels. We further improved and validated our data by removing all the outliers and examine past patterns and risks to determine the forecast and our predictions. We experimented with the data by selecting data from different time periods while removing the outliers and scaling the data. We ended up with an accuracy of 87%, which is pretty high. All right, this is our data set. We used the stock data from Apple, Amazon, and Tesla. We got the data from Yahoo Finance, and that there is a code on how we imported it. It includes the highs, the lows, the closing price, as well as the volume. Next, our data visualization. This bit of code right here is how we use to plot out the graphs for the trend of Tesla, Apple, and Amazon stock prices in the past year. And this is only for the closing prices, which is the last price of a stock traded during the regular trading season. And the graphs on the left here are the graphs for the volume, which is the total number of stocks being traded each day. And there again is the code that we use to write for the graph.
So we use pandas to get the daily returns. And basically the purpose of this was to analyze the risk of the stock. And then we created a histogram to retrieve the average daily return. So predicting the stock price, we are training the model based on past market performance. So we looked at like the open, the high, the low, the close for each stock, and we chose from 2015 to 2022. So the model will be trained on data in that time frame. And this graph is for the close price for Apple, Amazon, and Tesla from 2015 to 2022. And then we scaled the data. So the data set uses the stock's open, high, close, volume. And in the first line, we're making it so that the model uses only close price for training. And then we got the number of rows to train the model on. And we used 95% of that data, and the rest was used for testing. And then in the second block of code, we basically modified the close prices to be only between 0 and 1. So the model will only deal with smaller numbers. Then we trained the data. So in the first line, we created a training data set and a scaled training data set. And then we split it into X train and Y train. And then we stored it as a NumPy array and then reshaped the data. And then we tested the data. So we created a testing data set and a new array containing the scaled values in the first line of code. And then we created an X test and Y test data sets, and then converted that data to a NumPy array, and then reshaped the data, got the predicted values, and then found the root mean squared error.
We built the model using Kara's LSTM model, and we use dense layers to help define the relationship between the values within the data. We measure the loss as a mean squared error and fit the individual stocks data sets to teach the model how to predict each stock's stock price. The model's construction was a linear regression model, and it allows a clear view of the highs and lows of certain stocks and their changes over time. Below, we plotted the daily return of a stock and to take a better look at the possible risk of each of the stocks we chose. we plotted the performance for the prediction for the stocks for Apple, which is shown here, Tesla, which is shown here, and Amazon. The graphs show the prediction data and the actual values, which the prediction data are model created on its own. Our conclusions are that our model performed with an 87% accuracy, but we could have improved it by running more epochs or reducing the RSME somehow. We learned how to take past data to make future predictions and how to use the linear regression model to predict future stock prices. Choosing and collecting data from a more recent time period provides more accurate information with a minimal data set. Thank you for watching.